able to save this and post it up under chapter 18. Okay, so I'm going to just go through those slides for chapter 18 today, and I've embedded many of the quiz questions in there, so that's why I think that we won't have to spend too much time on the quiz next time. I've actually embedded a lot of the quiz questions into the slide, but we'll pick up any that we don't cover this time next time before we jump into our chapter on capital investment. Okay. Now, when Danny was going through the presentation, there was a lot of financial information, much of what we've been studying here in class. I think you recognize, for example, the income statement and the calculation of gross profit and the operating expenses, etc. So we sort of ate our vegetables going through all that and, learning debits and credits and all that, so we would be able to understand the nature of the information that's included in those financial reports. Now, you remember that Danny mentioned that there could also be non-financial information included in those reports as well. Okay, and investors are often interested in saying, well, yeah, okay, we can read your financials, but what are our sales going to have to be to break even? What is our capital budget going to be going forward in the future as we start to make further investment in the company? These are non-financial measures that companies will often want, or not companies, but investors, companies will want to provide it, investors will want to see it to understand issues about break even, etc. So we're still going to be using the financial information, but now we're going to be analyzing it in a way that will allow us to determine our break even in sales, what happens if we spend more on advertising, what happens if we're able to cut certain costs, etc. Okay, so we're really going to now be doing analysis using the information that we've learned about in the first, 3/4 of the class. Okay, so let's just go ahead and take a look here. And of course, I'm going to have my clicker doesn't want to participate, but maybe if I plug in the little receptor, that will probably tends to help. Okay, all right, so when we look at our costs, okay, when we look at money that we're spending, we're going to look at the behavior of the cost depending on whether the cost is considered a variable cost, is considered a fixed cost, or is considered a mixed cost. Okay, now these terms sound very technical, but they're very easy to understand. Let's start with variable cost. Okay, variable cost change with levels of production / sales. More importantly, they're going to change with our sales because we're going to want to understand how these costs are going to affect our net income, our break-even analysis, etc. Okay, so variable costs change with levels of, for this class, we're just going to worry about how it changed with the level of sales. Okay, so if I'm a manufacturer, my direct materials will be considered a variable cost because the more items I produce, the more items I sell, the more my costs are going to be because I have to include if I'm selling chairs, I have to include the cloth that covers the chairs, the wood that's the frame for the chairs, the rivets or whatever that I put into the chair, etc., right? Okay, so direct materials are a variable cost. They will change with the level of production. Okay, now we can also have direct labor. Direct labor will change with the level of production, so it is a variable cost. What is the labor? Whatever I have to pay the person to construct the chair is going to be considered if we're using chairs as our analogy here, whatever we are paying the labor to produce that chair is a what? Is a variable costs because we're having to pay that person. The more chairs we produce, the more we're having to pay them. At some point, we'll have to hire additional people if we keep producing more chairs, right? Okay, so direct materials, direct labor are considered variable costs because they'll change with the level of production. Okay, now when we talk about fixed costs stay the same. Fixed costs stay the same regardless of what? Production / sales. We could call this level of activity. If we wanted to be a little bit more generic, we could say sales, production. We could call that level of activity. Fixed costs will stay the same. So the rent on our factory building will be what? A fixed cost, because it doesn't matter whether we produce 100 units, whether we produce 1,000 units, whether we produce 0 units, you got to pay the rent on your factory building. I mean, your landlord is going to come and say, "Oh, did you have a rough year? No sales this year? Don't worry, catch me next year." They're going to expect what? They're going to expect their rent to be paid to them, aren't they? Okay. The depreciation on our factory building, if we own the factory building, depreciation on our factory / equipment is a fixed cost because it does not vary with the level of production. What happens? We say that we have a building that's going to last us 20 years. We take the cost of that building, divide it by the 20 years, then what? Then it's going to be the same regardless. Time marches on. It doesn't matter what our sales are, right? So typically depreciation on factory building is going to be considered a fixed cost. Now just a small footnote to that. If we're using the level of activities method for our depreciation expense, then obviously depreciation would have what? A variable component to it. But for our purposes, we're going to treat depreciation as a fixed cost. Okay? So we have what? We have our variable costs. Variable costs will stay the same regardless of the level of production. We have will vary with the level of production. Thus the term variable cost. Our what? Our rent on our factory building, our depreciation on our factory building, our fixed costs, they will stay the same regardless of the level of production. Okay? Now we can also have something called mixed cost. Okay? What happens with mixed cost? Well, mixed cost, as you might tell by the name, have both what? Have both a variable and a fixed component to them. Okay? They have a little bit of both. A little bit of variable, a little bit of fixed. Okay? What's a good example there? Our utilities are often a mixed cost. I'm just going to write it over here. Utilities tend to be mixed. Utilities tend to be mixed. What happens? You want electricity at your house, don't you? Okay, so you go and you sign up with PG&E to get electricity at your house. What happens if you sit there in the dark all month? You turn everything off and you just sit there. No electricity. You don't ever turn on a switch. Will you still get a bill from PG&E? Pacific Gas and Electric? You'll still get a bill from them for, I don't know, $10, whatever, because you have the privilege of turning on the light, don't you? So that part is fixed regardless of how much you use your lights, right? Now, if you're like me and you're constantly leaving your TV on, like my TV never goes off. It's just on 24 hours a day, okay? If you do that, then what? Then you're going to start to run up a larger and larger electricity bill, aren't you? Okay, so that part is variable. You're producing a lot of sales. You're going to be what? You're going to be using more electricity in your factory. Your utility bill is going to be higher, but you're still going to pay that $10 a month, right? So it has both a fixed and a variable component to it. Yes, sir.
Does the fixed cost include when, like, like, say you built your factory in the middle of nowhere and you had to install a bunch of power lines there and they charge you like maybe $5,000 to do the initial work? Does that include as part of the fixed cost?
That is a fixed cost, and I'm assuming that, you know, we are owning that we had to pay, and we would depreciate that, and thus it would become a fixed cost that we would take as we depreciate it. I'm assuming we own that once we have made that investment. Okay. Okay, so we have what? We have mixed costs, we have variable costs, we have our fixed costs. Now, if we were going to try to graph out our mixed costs, let's just try that for a second. What would happen? There would be that fixed component. This is the number of units down here on the x-axis. On the y-axis, we're going to have dollars. And there's that fixed component, whatever, that $10 a month we have to pay even if we don't turn the lights on, right? Okay. Now, once we start to turn the lights on, what's going to happen? Then we're going to have our costs go up by the number of units that we use, whatever the kilowatt amount is per hour, whatever, right? So when you looked at mixed costs, they have this sort of graphical depiction, which is your fixed cost, always going to happen regardless of number of units, and then what? And then our total cost line, this is our total cost line, is going to be pushed up by the fixed cost and then increase as we produce a certain amount of units, right? Now that is a graphic depiction of fixed costs. If I combine all of these costs together, my fixed and my variable, then my entire cost behavior is what? Is this depiction, isn't it? I've got fixed costs, whether they're part of the mixed cost or by themselves fixed costs. I've got my variable costs, whether they're part of the mixed cost or by themselves variable costs. This graphic depicts my entire cost, doesn't it? So that's basically what? Fixed up to a point, and then it starts to go up as the number of units are produced. So what happens? We could actually predict our cost by creating an equation that will represent this graphic, this behavior. And that equation, and I'm not going to insult anyone's intelligence, or at least I'm not trying to. I may insult your intelligence, even though I'm not trying to, is depicted by the equation y equals mx plus b, where y is what? Y is our total cost, isn't it? Okay, the what? Dependent variable. The what? The m is going to be the slope of the line. M is the slope, and for us, our slope is our variable cost. As we add units, this is how our variable costs go up, right? Okay, so variable cost times the number of units we're using, whatever it is, number of units we're producing, plus what? B, this is the B portion, that's our fixed cost, isn't it? It's the same regardless of the level of production. Okay, so once we put it into this cost equation, y equals mx plus b, all we would have to do over a period of time is observe what is our total cost month to month, what were our what? What are our fixed cost month to month, and we should be able to do then what? Predict what our variable cost per unit is, and then we can set up an equation, total cost equals what? Variable cost times the units plus fixed cost, and predict what our costs are going to be over any period of time that we would like to analyze. Okay? And so once we do this, and once we have set up this sort of equation here, then we can sit here and say, well, how many units do we have to produce to break even? How many units do we have to produce to meet a certain target profit, etc. Okay, which is sort of the type of analysis that we'd want to be doing when we're initially thinking about getting into a business. As we start to get more sophisticated with the reporting packages and whatnot, our investors potentially would want to know that sort of, and we consider this non-financial information, even though we're using the financial data to analyze it. How many units you have to sell to break even is considered non-financial. Okay? Okay, so obviously to be able to break our costs into the variable versus the fixed component, we have to know the difference. And so an executive salary would be an example of a fixed cost because the person gets paid whatever they get paid regardless of sales, regardless of production. As we've seen, our direct labor, our direct material are both variable. Depreciation tends to be fixed. Indirect labor is a variable cost. Indirect labor is basically if we have to pay supervisors. Supervisors are going to do what? They're going to be, supervising several employees, so they're not charging their job directly to each job, so we would call that indirect labor. Delivery expense, if we're paying it, is a variable cost. Television advertising is fixed. Okay, the advertisers don't say, well, we'll charge you this if you sell that, and we'll charge you that if you sell this. They say, hey, you want to advertise with us? It's $100 per advertisement, whatever, and if you have 30 of those in a month, that's going to be what, $30,000, whatever it is. Indirect materials are things like grease, that sort of thing that we would consider to be variable. But notice our labors and our materials are all variable. Our fixed are things like our executive salaries, depreciation, rent, advertising. Okay. For this class, I will not require you to sit there and look at a list of costs and decide which are fixed and which are variable. We will call them out in the problems as such. Okay. But just so you can kind of see how that looks. Period or product cost, really beyond the scope of what we're trying to do right now. Okay, so we're just going to worry about the fixed versus variable. Okay, all right, so we have this equation, total cost, and where's my little graphic? What happened to the graphic I put in here? Do you guys have a graphic on yours? What do I do, not save it? Okay. I guess I was sitting there and hallucinating what I was doing this morning. It certainly seemed like I did what I wanted to. Okay, here it is. It's just not in the best. Oh, I see. I see how I want to do this. Okay. Okay, so we're good. We'll come back to that other thing in a minute. I remember now what I was trying to do. Okay, so what we're going to be looking at really in this chapter is something called contribution margin. Okay, contribution margin is used to first cover fixed expenses, and any remaining contribution margin will contributes to any operating income. Okay, now how do I calculate the contribution margin? Contribution margin is sales minus my variable costs. Sales minus variable costs equals contribution margin. Now think about this for a second. If I am having a variable cost of, I don't know, $5 per unit, and my sales price is $7 per unit, I have to do what? Before I can make a profit, I first have to cover those variable costs, don't I? Okay, so I'm only left over per unit with what? $2. I can't sell an item unless I produce it. If it cost me $5 to produce it, then five of my $7 of sales price is going towards covering the cost of producing the unit I'm trying to sell, right? Sell it for $7, cost me $5 to make it. I can't sell it unless I have the unit, and I got to spend $5 per unit to produce this thing, don't I? So I'm only left with $2 per unit left to do what? To cover my fixed costs, which are not going to change regardless of production. I'm going to have to cover those fixed costs, right? And if there's anything left over, then that will go towards operating income, right? Okay. Sell an item for, make up a number, $15 per unit. Your variable costs are what? $10. So right off the top, $10 of my 15 is going to cover the thing I'm trying to sell, right? So what am I left with now in this example? $5. $5 now has to cover first my fixed cost, and then if there's anything left over, it'll go towards my operating income, right? Okay, so we set up our contribution margin as our sales minus our variable costs. Now, often we're going to want to know what the contribution margin is per unit. So to get that, we would take our sales per unit minus our variable cost per unit. That'll give us our contribution margin per unit. Or we could do what? Take the entire contribution margin and divide it by the number of units. That would also obviously give me my contribution margin per unit, right? Okay. Okay, once I know what my contribution margin per unit is, I can now do my break-even analysis, and I can do my break-even analysis in terms of unit sales. Okay, so the way I will always tell you to set up your break-even in units calculation is to take your contribution margin per unit times your break-even sales in units. Guys, that's the unknown. I don't know what my break-even in sales units is yet when I'm making this calculation. That has to equal what? My fixed expenses. And if it equals my fixed expenses, then I'll have covered my fixed expenses. I'll break even. I'll have a net income of what? Of 0, an operating income of 0 at that point, right? Okay. Now, I simply do the algebra at that point. And don't be fooled by this slide. You kind of see this in its own little capsule here, and you think, okay, that's all I need to know. This is a good way to mess these up if you just memorize this. You're better off thinking about it like this. Break even is equal to what? My contribution margin per unit times my break-even sales, the unknown, equals my fixed expenses. Doing the algebra, if you divide each side by contribution margin per unit, that will give you the number of units you need to break even. A valuable piece of information for you if A, you're even thinking about getting involved in an endeavor. You may do this on the back of a napkin. Okay, I've had a couple of teaching business ideas in my head, and I've sat there and kind of did a little back of the napkin break-even analysis, and I've gone, forget that. I'd have to sit there and, work day and night in order to get what I want, and I add in a target profit there when I'm doing that, because nobody wants to do something to break even. But if you're looking, and the number of units that you have to produce to break even are some tremendously huge number that you have no way of reaching that level of production, you quickly discard that idea, don't you? Now, let's say you go ahead and you do that on the back of the napkin type of thing, and it looks pretty good. Then you're going to want to formalize that analysis, because you're going to have potential investors that would sit there and say, we want to see what the break-even analysis is. And that's the kind of non-financial information that you might include in your reporting package. Okay? So let's just go ahead and mess around with some numbers here. And they got this company in this example, and the bikes sell for $500 per bike, and the variable cost per bike is $300, and we have fixed cost of $80,000, how many units will the company need to sell to break even? How many bikes? Okay, and as I said, first set it up, guys, and especially in the early stages when you're first starting to look at this stuff, it's important to set it up so that you really make sure you understand what's going on. I've got a contribution margin per unit of what? 200 here. The $500 minus the $300 variable cost, $500 sales price minus $300 variable cost, gives me a contribution margin per unit of 200. I will multiply that times my break-even units, whatever that is, and I don't know yet. That has to equal my fixed cost, doesn't it? I plug in the numbers. Contribution margin per unit is 200. 200 contribution margin per unit times my break-even units, whatever that is, has to equal 80,000 before I can break even. I divide each side by the $200 contribution margin per unit, and that means I need to produce 400 bicycles in order to break even, don't I? And then if I just wanted to turn that into a dollar figure, I would take 400 times the $500 per bike. That means I have to generate $200,000 of sales in order to break even, right? And so these are the type of things that you'd be talking to your investors about and saying, well, we think that we can sell easily, 400 bikes, no problem. We think the demand in the market for this type of bike is 800 bikes, whatever. And you can start to talk around that sort of an analysis. Question? Okay, good. Now, the proof here is the financial report in which we're saying, hey, 400 bikes, it's what, $500 per bike, that's 200,000 of sales. Variable cost, 400 times $300 per bike is 120,000. 80,000 is our contribution margin. Unfortunately, that's just going to cover our fixed costs, right? Okay, but we can see how we are going to prove that in a financial statement format. Now, what I was looking for before, I thought I had put it before this, and then I decided, no, I'll put it after this. The big question is, well, that's beautiful. If I know what my variable costs are, if I know what my fixed costs are, then I can do that. If I don't know what my variable costs and my fixed costs are, I'm kind of stuck here, right? Okay. So, since this fits the equation of the line, TC equals total cost equals fixed cost plus variable cost times the number of units, what I could do is sit here, and if I knew that my variable costs were 0.03 per unit, and I'm going to produce 2,000 units, and my fixed costs are $40, I could predict my cost at $100, right? But how do you get this equation to begin with to be able to plug these different numbers in? Okay. Now, what I'm going to show you here is a baby analysis. Okay, this is what they do. You guys probably learned about this in, elementary school, in nursery school. They had the blocks, the y equals mx plus b blocks, okay? But this is just a baby analysis here in which we do what? We sit here and we have y equals mx plus b. And what we do is we look at the number of units, okay, that we're going to be expending at any point in time that we're going to producing. Here's our units. Here's our total cost. We've got our units, we've got our total cost. Now what we're using here is something called the high-low method. High-low method is going to take the highest number of our cost, which is 9,800, versus the lowest cost of our total cost. The total cost is the y, isn't it? So that'll give us what? Y2 minus Y1 on the top. And then we'll look at what? The high, low of the units. Okay, so the high number of units is what? Is, I guess, this June 850, and the low is February 450. That's going to give us what? X2 minus X1, the change in Y divided by the change in X, gives us the slope, which the slope is our variable cost per unit, isn't it? Okay, so when you take a look at this thing, if we plug in the numbers, our high cost was what? Our high cost was this 9,800. Our low cost was a 7,400. So we've got $2,400 the change in Y, or the change in total cost. And we went from what? 850 units as our high. Our low was the 450 units. That's a change of 400. X2 minus X1. So our variable cost per unit is what? Is $6. Did we figure out the variable cost? Did we figure out the variable cost? Okay, now, the problem with this high-low method, and the reason I call it a baby method here, is that what? It's sitting here, and it's picking the low cost, and it's picking the high cost, and then saying that the whole cost behavior is linear like that, isn't it? Meanwhile, if you really were to observe the points, they don't all line up on that line. They are not behaving linearly, and that's usually the case. So there's a major limitation to the high-low method, and that costs don't line up on a line perfectly like that you can predict the cost reliably like that looking at the high and low. Can you think of another method that might take a situation like I've drawn up there in the blue and use something a little more sophisticated to come up with the prediction of the cost behavior and create a line equation for that? Yes, exactly. Regression analysis, right, which is pretty easy these days to do inside of Excel. You're, of course, going to have to observe your what? Your total cost at different levels of production, and the more data points you have, the more reliable. But the regression analysis will use statistics to see what the difference is between the assumed line and the different points on that line and give you a pretty reliable estimate of whether there's a correlation between the units and your total cost. And if there is, then what? Then you'll say, okay, we can use that line to predict our cost. Now, they won't be perfect. It won't be perfect. Why? Because there are some costs that what? That even though you think they're fixed, sometimes they get variable for some reason. Something happens that makes them not a fixed cost, and so the thing won't line up linearly for you. Well, that's something you're going to have to live with, right? The beauty about accounting data is that if we're a little bit off, nobody dies. If it's a bridge and you say, well, this didn't quite turn out right, but that's okay, and down everybody goes one day, right? With the accounting, okay, we're going to do our best estimate, but we know we're full of estimates in these financial reports, aren't we? And we warn everybody of that. We just don't want to be ridiculous in how we do our analysis, right? Okay? Okay, now again, I'm not holding you accountable to the high-low method. I'm not holding you accountable to any kind of regression analysis. All I want you to be able to know is that there are tools out there that would help you predict your fixed cost, your variable cost, your total cost. Once you have that, then you can start to do the analysis that I am going to hold you accountable for, which is what? Calculating break even, like we just did. Okay? Okay, good. And then they came up with the equation for the line. Once we knew what our total costs were, we could pick either the high or the low. Our total cost, we know that it's $6 per unit. We plug in the high number of units. You could use high or low. Just depends on whether you like to be high or you like to be low. If you like to be high, use the high number to come up with what? With the then fixed cost by taking your variable cost at the high minus your variable cost at the high gives you your what? Fixed cost. And it would also work if you use the low there instead of the high. Okay, but again, I'm more interested in once you have these factors, your fixed cost, your variable cost, your number of units, can you predict for me what your total cost is going to be and thus do your break-even analysis? Okay? Okay, so this is more than we need now at this point. Okay? So we've done break-even. Let's just take a look then at Target profit. Target profit is something that you will simply add to your fixed cost. So you say, okay, I know that we have to produce, 400 bikes to break even. How many bikes do we have to produce if we want to make a target profit of X, whatever it is? Okay? Because nobody just wants to break even, right? You want to see, well, if I want to make so much money, how much will I have to produce, will I have to sell? Okay? So when you take a look at the target profit now, we already know our fixed costs are 80, and now the company added in that they want a $20,000 target profit. Piece of cake. You do what? You simply add the target profit. You take what? Your contribution margin per unit, the $500 was the sales price of the bike minus the $300 of variable costs. And you divide that, and that means that I would have to sell 500 bikes if I wanted to produce a target profit of 20,000. And just the proof in the pudding here is the financial report. 500 bikes times $500 per bike is 250,000. $300 per bike times the 500 bikes is $150,000 of variable costs. I have $100,000 now contribution margin, which first goes towards fixed cost, and then any remaining amount goes towards the target profit, right? Of 20,000. Anybody got a different target profit? Is 20,000 good enough for you? How much target profit you want? Go ahead, get greedy. 100,000. You want 100,000? Who wants 100,000? $1 million? Is that per year or what? Let's do 100,000 just to keep the numbers somewhat manageable. Okay, so if the target profit's 100,000, say per year, at least in the early going, right? And our fixed expenses are what? 80,000? That means we have what? 180,000, and we have to cover our fixed costs and our profit with the $200 contribution margin per bike we have left over. So that means we got to sell, what is it? How many bikes? 900 bikes. Now, we're sitting there and we're looking at our factory or whatever, and we know that the factory can only produce 600 bikes, and we're saying we're not willing to get into this unless we can make 100,000. We're done. We're not doing this. This is stupid. Who wants to do that? I don't want to sit there. Do you know how long I'm going to have to sit there all day to make 900 bikes? Forget about it. I don't want to do this. If you're sitting there, in fact, I can't sell 900 bikes. I have my market analysis. There's no way I can sell 900 of these bikes. We're not doing this. Now, if you sit there and you say, what happens since we can't sell 900 bikes? What happens if we drop the sales price to $400 per bike? We're not going to be able to sell 900 bikes at $500 a bike. There's just not that many people out there that have that sort of disposable income on a bike, but we think we can get 900 people to pay $400 a bike. Now, what's our variable cost per bike? Variable cost per bike is still $300, isn't it? So now we've got a contribution margin of $100 per bike. We take the $100 per bike and we divide that. What's that come to? 1,800? Huh? 1,800. We're saying, well, now we got to sell the bikes for 1,800. This is getting worse as we go along, isn't it? Okay, but you can sit here and play with these numbers in such a manner to where you think, hey, we have enough, we can sell the bikes at a certain price. What if we change the price? What if we change the price to that? By sitting there and doing this sort of break-even target profit analysis. Okay? Okay. Question. question? Okay, good. There's the proof. Let's take a look at a couple of questions. And like I said, as I said at the beginning of class, a lot of these questions are repeated in the quiz, but I went ahead and embedded some of them into the slides just so that we can kind of see how the quiz questions apply to this very specific slides that we just looked at. Okay? Now they say break even in units sold will decrease if there is an increase in what? And the answer is selling price, but let's just use the example that we've been using here to see how that would work. So if we increase the selling price of the bikes to $550 and we have a what? A variable, that's variable cost. If you're wondering what's VV, I don't know. Variable cost, okay, per unit is 300, just leveraging off of the facts that we had in that example. That would mean we'd have a contribution margin of what? 250 per unit, okay? Now we take the 250 times the break-even units has to equal the fixed cost of 80,000. You do the division there, and that means that we would have to sell what? 320 bikes in order to break even, right? So in order to what? Instead of the, what did we have before? 400 bikes? Before we had 400? So the break even in units sold decreased from 400 to what? 320 by increasing the sales price, didn't it? Okay. Okay, good. Let's take a look at this question. And this wants to say, what is the contribution margin if we, instead of sell 6,200 bikes, we now only sell 5,800? Maybe we're anticipating a slowdown in production, slowdown in sales, and we want to still see what we'd have as a contribution margin. Now, they give you all this nonsense down here. I don't believe in that, okay, because I'm saying, well, look, if they gave me the sales, they gave me the variable expenses, they gave me the total contribution margin, didn't they? Then what? Then I would take that total contribution margin and divide it by the 6,200 units that they were producing. That means we have a contribution margin per unit of $9, don't we? 136,000 is the sales, 400 is the sales at 6,200 units. Variable expenses, they tell me for the 6,200 units is 80,600. That means I have a contribution margin of 55,008. I take that 55,008 divided by the number of units, I have a contribution margin of $9 per unit, don't I? Okay. And then I go ahead and I say, okay, well, if I produced only 5,800 bikes, instead of having a contribution margin of 55.8, it'd be $9 per unit times now, instead of the 6,200 bikes, 5,800 bikes. That gives me contribution margin total of 52,200. Okay? So this contribution margin per unit allows you to do what? Predict different numbers just by simply plugging in a different number of units, etc., right? Okay. Okay, good. Let's take a look at this one. And very similar situation. They have a contribution margin of 83.6. Divide that by the 4,400 units. Gives me a contribution margin per unit of 19 units. If I sat there and instead of my sales being 4,400 units, it was 4,700 units, now I'd have a contribution margin of 89,300. Okay. Now the reason I numbered these down here is I'm just pointing out to you that when I give you the quiz questions and I give you the solutions that are provided by the textbook, you know, I don't know what they're trying to do other than give you 4 opportunities to mess this question up. Okay, the more calculations you make, the more likely it is you're going to make a mistake, right? I can bust this down to what, 2 calculations? Okay. Okay, good. Now that we are somewhat comfortable with the way we calculate contribution margin, let's go ahead and let's take a look at a problem in which now we're asking break even. This is more likely what you're going to see on your final than those sort of practice questions there that were the last couple of ones we did. Okay, they tell me sales price is $230. Variable cost is $66.70. So my contribution margin per unit is $163.30 per unit. They tell me that the fixed cost is this $212,290. So I simply take the contribution margin per unit times my break-even sales. I don't know what that number is. That's the number that's going to be the answer to the question, isn't it? Equals my fixed cost. I take the what? The $163.30 per unit divided by each side. That means that my break-even is 1,300 units. Can you produce 1,300 units? Can you sell 1,300 units, right? You can start to ask those questions once you've done this calculation. Okay? Okay, good. Let's sit here and try this one. $40 per unit is the variable expenses. $22 per unit is the, $40 per unit is the sales price. $22 per unit is my variable expense. That gives me contribution margin per unit of 18. I take my contribution margin per unit times my break-even sales has to equal my fixed cost. Break-even sales is the unknown here. I simply divide each side by what? My contribution margin per unit, and that gives me a break-even sales here of what? 4,600 units? Did that come out even? In other words, when you run that into your calculator, does that come out evenly to 4,600 units? I'm asking, I don't know. $82,800 divided by $18. Does that come out even to 4,600? It does come out even to 4,600. Okay, that's fine. What if it came out to 5,900.5? What would be the answer? Huh? You have to, well, yeah, with the 0.5. Let me change it. What if it came out to 5999.3? You have to round up because you can't sell a 0.3 of a unit, right? So in these problems, you always round up to the next whole unit, right? Okay. Okay, good. This one worked out fine. I think there's some where there's a fraction of a unit. You always round up to the next full unit. Okay, good. Let's take a look at this one. Selling price is $190. Variable expenses $91.20. That gives me $98.80 per unit. And the fixed expenses are $424,480. And they want a target profit now of $16,000. So it's going to be what? Contribution margin per unit times, and now its target profit sales is going to equal my fixed cost, 424,840, plus what? Plus the 16,000 target profit that I want to make now, right? Okay. So when I do the math on that, I get 98.90 times target profit sales has to equal the sum of those two, which is 448.40. 448.40 divided by $98.80 gives me a what? Target profit units of 4,462. Maybe this is the one that didn't come out even. I forget. There's one of these that doesn't come out even, but we round what? Up to the next unit if it doesn't come out even. Okay. Okay, good. Now you can show this graphically. Guys, I'm not going to belabor this. You know, just to give you some ideas of putting up your presentations. You can say, this is our target profit area. We anticipate whatever. Okay. Now, there's also something called contribution margin ratio. Okay? Remember when we got the break-even sales and it was 400 units? And then I had to do that extra calculation of taking the 400 units times the $500 per bike to say what our sales was going to be in dollars, 200,000. Okay? A quick and dirty way to come up with that same set of information would be to come up with my contribution margin ratio, which tells me what percent of every sales dollar goes towards my fixed expenses and then my my target profit, whatever it is. Okay, and in this particular case, the contribution margin ratio is 40%. It's what? It's the contribution margin of $100 divided by the sales price of $250. That means 40 cents or 40% of every sales dollar goes towards first fixed expenses and then profit. Okay, so now I can what? Quickly figure out what my sales price in dollars is going to have to be by using the contribution margin ratio. Okay. Now, if I do it the long way, I'm going to have to say $200 times break-even units equals my fixed cost of 80,000. $200 is my contribution margin per unit. Do the math. I get my 400 units. Then I have to multiply it by 500 to come up with 200,000, right? I could have just used the contribution margin ratio, which takes my fixed expenses and divides it by the contribution margin ratio. That will give me my break even in sales dollars. In other words, what? 0.4 times my sales in dollars, the unknown here, has to equal $80,000, since 40% of each sales dollars or 40 cents on each sales dollar goes towards my fixed cost and then my profit, right? And so when I do the math there and just divide 0.4 by each side, it automatically gives me the answer in dollars, doesn't it? So I don't have to do that extra step of saying, well, now that I know what the break-even in sales units is, let me multiply that by my sales price to turn that into dollars. I automatically get the answer in dollars by using the contribution margin ratio. It's a shortcut, guys. It is a quicker way of getting the answer in dollars than having to sit there and take my break even in units and then multiply that by the sales price per unit. I simply take my contribution margin ratio and divide it by my fixed costs, or whatever my fixed cost plus my target profit is, and I can come up with all kinds of different numbers quickly as to what my sales in dollars has to be. Okay. Okay, good. You come over and let's try this now, that 100,000 of target profit that we want here. Is it 100,000? Yeah. Fixed costs are what? Are 80,000. We divide that by the contribution margin ratio. Our sales in dollars now would have to be 450,000. Okay. All right, so let's go ahead and let's mess with some problems here dealing with contribution margin ratio. And we've got this Mac Corporation contribution ratio is 16%. Fixed monthly expenses are 44,000. The company's sales are 299,000. What is the best estimate of the operating income for the company? So we do what? Since 16% of each sales dollar first is going to go towards fixed cost and then profit, we simply take the sales of 299 times 16% means that my contribution margin is 44,000, isn't it? Contribution margin ratio 16%. 16% of each sales dollar goes towards my what? Towards my first fixed expenses and then my profit. My fixed expenses are what? 44,000. So if I take the 16 times the 299 gives me 47,840. minus the 44,000 means that I'm going to generate a profit of 3,840 on sales of 299, right? Question? Okay, let's try another one. Total sales 600, variable expenses 120, fixed expenses 300,000. What is the break-even point next year in sales dollars? Well, first, in this problem, I got to get the contribution margin, don't I? Which is the sales price minus the variable cost. Gives me contribution margin of 480. I take the contribution margin of 480 and I divide it by the sales price. That gives me contribution margin ratio of 80%. 80% or 80 cents of each sales dollar is going to go first towards my fixed expenses, and then any additional amounts left over are going to go towards profit, right? So I go ahead and I say, well, 80 cents contribution margin times my break even in sales dollars has to equal my fixed expenses of 300,000. I do the math on that, and that means I have to have sales dollars of 375,000. Okay, let's try this one. Contribution margin, $8 per unit. Contribution margin is going to be what? The sales price per unit divided by the contribution margin per unit, or 0.4. What is the amount of contribution margin if sales volume increased by 30%? Now, for some reason, in some of my classes, probably not this one, I have students that have trouble with the idea that if I take 300,000 and I multiply it by 1.3, that is increasing that 30%. Any problem with that? I didn't think so, but you'd be surprised. I've spent entire lectures explaining that, okay? So 1.3 is a 30% increase, so that's 390,000 times what? Times the 0.4 contribution margin ratio per unit gives me 156,000 is my contribution margin in sales dollars. 156,000. Okay. Okay, good. Now, once we have these different tools in our tool chest, whatever, now we can sit here and start to do different types of analysis and see what different decisions will do to my profit, will do to my break-even point, etc. Okay? So what is the profit impact if this bike company can increase unit sales from 500 to 540 by increasing the monthly advertising budget by 10,000? Do you think we should do this? Now, my sense is the guy thinks no because he didn't even put his briefcase down long enough to listen to this, okay? But let's go ahead and let's use some of these tools now that we've thought about, that we've learned about, to see what we think, okay? And so what happens? If you were to stay where you were going to have an operating income of 20,000. If you increase the number of bikes from what? From 500 to 540. 540 times the $500 per bike would increase your sales to what? 270. But it's also going to increase your variable cost $300 per bike, right? Okay. So you're left with, yes, a higher contribution margin, but what? Your fixed expenses went up by 10,000 while your contribution margin only went up by 8,000. This is a bad idea, isn't it? Okay. Now you could do it just on the contribution margin itself, which was $200 per bike. We're going to increase our sales, remember we said, by 40 units. So if we increase our sale by 40 units, that's an increase in our contribution margin of 8,000 at the cost of advertising expense of 10,000. We're not doing this, are we? There's no way we're doing this. What if the number here was increase in operating income of 1,000? Let's say it increased at 1,000. Would you do it? Would you do it? In textbooks, yes, right? In reality, no. Are you kidding me? I've got to sit here and do this advertising campaign hoping that I'm going to get the what? Increase in sales, and all I get out of it is $1,000 a month or whatever per month or whatever. So you'd probably want to build in some cushion in there for the potential that this might not work out, right? Or it's not going to work out as great as you plan. Your sales aren't going to go up as much as you plan. You could introduce into this, and we won't in this class, probability analysis, right? What is the chance that we'll sell 0 more bikes? What is the chance that we'll sell whatever it is, 40 more bikes? What is the chance that we'll only sell 20 more bikes, and see how that works out for you, right? Okay. This guy can't even get across the street. Okay. All right. Now, you come over and we say, what if we can get higher quality materials, which are going to increase our variable costs per unit by $10, but we're going to be able to sell 80 more bikes as a result. I guess once word of mouth gets it out there that our bikes are the bomb or whatever. Okay? And so what happens? Sometimes the best way to do this is just go ahead and see how the numbers run the way they've done here, the long way. And you can see that, yes, we have increased our variable cost $10 per bike. So now, but we've increased our sales, so we have a bigger contribution margin. And so we have what? We have a higher operating income. So this one we might do, right? To generate this 10,000 or what is it? Yeah, $10,200 more of sales per month. Of contribution margin per month. Of operating income per month, excuse me. Okay. Well, how about a couple of moving parts? Let's say we cut the selling price by $20 per unit, increase advertising budget by $15,000 per month, and increase sales from $500 to $650. This sounds promising, doesn't it? Okay. So we go ahead, we run the numbers. Yeah. $2,000 more per month of income as a result of doing this, right? Now, again, I'm looking at that and saying, is that enough of a cushion? Because there's a chance that we'll do all that and we'll sell the same number of bikes, right? And then we're going to wish we hadn't done this. Okay. So let's say we're breaking even. We're making target profit. So we're happy. And then we get approached by a customer that says, look, I'm going to buy a bunch of bikes from you, 150. But I don't want to pay the $500 per bike because I'm buying in volume from you. How much can you sell me the bikes for? And let's say you look at this whole situation, you say, well, for me to even bother with this new potential customer, it's got to bring in $3,000 more a month for it to even be worth my time to do that of a profit. Okay? So how would I do the analysis to see if I want to take on how much I want to sell the bikes for? Okay? Now what happens? 3,000 bikes divided by 150 bikes means that I need to, not 3,000 bikes, $3,000 of profit divided by 150 bikes means I need to make $20 per bike, right? If the bikes are costing me, variable cost, $300, then I should be able to sell the bikes to this new potential customer for $320 per bike, and that will allow me to do what? To generate this operating income that I want at $3,000. So I tell the guy, hey, okay, $320 per bike. Do we have a deal? Now, what happens when you start selling the bike for $320 per bike? What's the first thing that's going to happen? You're usually selling the bike for $500 per bike. What's the first thing that's going to happen when the word on the street is that you're selling them for $320? Everyone else is going to start to question, why are they paying $500, right? Okay? So they're going to come to you and they're going to say, I want it for $320. Now what? What do you say to him? Huh? Now you start saying, hey, yeah, well, come on in. Are you free for lunch? Come on in. We're going to talk about this. We think we can work something out. You don't tell them no. You sit there and you say, and you sell them 550 bikes for $310. I don't know, whatever it is to make it worth your trouble, right? Okay? Okay, but breaking our costs into the contribution margin opens up an awful lot of analysis to us, doesn't it? We're taking our variable costs and our fixed costs and treating them separately. Okay, guys, I want to go ahead and finish this. We'll probably get out a little bit earlier. I don't see any point in taking the break now for the 3 or 4 slides we have left. Okay, so hang tight. We'll finish early. Variable expense ratio is simply the complement of our contribution margin ratio. Okay, so if we have a what? Contribution margin ratio of 40%, then we have a variable cost ratio of 60%, right? It's the complement. 1 minus the contribution margin ratio gives you the variable expense ratio. Okay, and that's all this problem did. It gave me a variable expense ratio of 35%. So, okay, I had to calculate what the contribution margin ratio was, which is the complement. 1 minus 35% is 65%. 65% times the fixed cost of I see. And then they say if sales increase by 75,000, that will give me extra contribution margin of 48,750. And if they're going to sell or I should say purchase advertising for 25,000, they'll make an extra 23,750. So all we did there was make you calculate the contribution margin ratio by knowing that it's the complement of the variable expense ratio, right? Okay, let's take a look at a different way of looking at how you might structure sales commissions, assuming now you know something about the contribution margin of your various products, okay? And in this example, we have these 2 bikes, or what is it, surfboards now? The XR7 and the Turbo. The XR7 sells for $100 and generates a contribution margin ratio of $25. The Turbo sells for $150 and earns a contribution margin ratio of $18 per unit. Now, as from a company standpoint, which one do you want to sell more of? The $100 one or the $150 one? $100 one, bigger contribution margin ratio, right? Meanwhile, if you're offering your sales people, and I think they said, well, I guess I made this number up. If you're offering your sales people, say, a 10% commission for each board they sell, they're going to be all over trying to sell the 150 one, aren't they? Because they're going to get a better sales commission. Meanwhile, we're losing what? $7 per unit of contribution margin ratio here because of how we've set up our commission program. So it would make more sense to do what? Set up your commissions based on the contribution margin ratio, right? You'll get whatever percent of that ratio is. And it can still mathematically work out to what they will get the same amount of commission, but you're leveraging it off of what? Off of contribution margin ratio instead of sales price. Question? Which is what I just said. Okay. I'll tell you what. Let's go. We can go. And what we'll do next time is we'll look at the quiz. Look at the quiz and see if there's any additional questions there that we haven't worked already, because I think I embedded just about all of them in there. If there are some additional ones, we'll quickly go through those and we'll jump ourselves into the next chapter dealing with capital budgeting. Please make sure you signed in, guys. Very important. If I'm going to do the final online, but only for those individuals that are coming to class. The people that aren't coming to class, they're going to have to come to class and take it in person. Okay? All right, guys. Have a good rest of the day. I'll see you on Wednesday. Mm-hmm. Huh.
Like initially if we were taking it on like in class. So if we take it online